Now let's do the 30th problem. That is, if f of x, if the function is mod x plus 1 when x is less than 0, or 0 when x is equal to 0, and mod x minus 1 when x is greater than 0. We have three functions, okay? Then for what values of a does the limit exist when x is approaching a? Now here is asking for what values of the function when x is approaching a, the limit exists. So now here a is a real number in a number line, okay? So that can be written as, see, if this is 0, this is 0, a can be this here, a can be the point here, a can be this, a can be this, a can be this, and a can be this, okay? A can be any points in the number line from infinity to the negative infinity, okay? This can be a, this can be a, this can be a, this can be till infinities, okay? And a can also be 0. Now for what values of a does the limit exist? Does limit exist at this point when of a? Does limit exist at this point, at this point, okay? At what values of a does the limit exist? So we have to find out in when a is less than 0, does limit exist anywhere in this line? When a is greater than 0, does limit exist anywhere in this line? And when a is equal to 0, does limit exist at this point, okay? At all these points, any of the points. So let's take when a at this point, when a is less than 0, okay, at this area. So now before that, let's change the function, okay? Let's remove the mod and rewrite this, okay? Now we all know that when x is less than 0, mod x can be written as minus x, okay? So we can write this as mod x as minus x plus 1 when x is less than 0, and 0 when x equal to 0, and for greater than 0, mod x will always be positive, okay? Positive. So we can write x as mod x as x itself, okay? So x minus 1 when x is greater than 0. And this is the function, okay? We have rewritten it in this form. Now if we take the number line, and this is 0, and some point here in when a is less than 0, okay? A is less than 0, we'll take a point here a, let this be the a, and x is approaching a from both sides, okay? Now the function for less than 0 is this one, okay? Minus x plus 1, okay? So now when x is approaching a from both sides, this will be the distance h, and the position of x in the LHL will be x is equal to a minus h, and for the RHS here will be this right hand side will be the position of x will be x is equal to a plus h, okay? Now as x is approaching this point a, the length of h decreases and it's trying to become 0, okay? So we can write h is tending to 0, okay? So the limit LHL, now the left hand limit will be limit f of x as x approaches a from the left hand side is equal to limit f of, this will be x will be a minus h as h approaches 0, h is becoming 0, the length, which is equal to, now let's put let's replace this x in the function with a minus h, okay? So it becomes minus a minus h plus 1, okay? H tends to 0, which is equal to limit, now this can be written as minus a plus h plus 1 as h tends to 0. Now putting the value of h in the function, we get minus a plus 0 plus 1, or minus a plus 1. This can be written as 1 minus a, okay? So this is the LHL, left hand limit. Now the right hand limit, RHL, limit f of x as x approaches a from the right hand side, that is a plus, is equal to limit f of a plus h. Okay, now x is replaced with a plus h as h tends to 0, which is equal to limit, now replacing this x in the function with a plus h, so minus a plus h plus 1, h tends to 0, okay, which is equal to limit minus a minus h plus 1. Okay, let's take the minus inside. H tends to 0. Now replacing h with 0, we get limit minus a minus 0 plus 1. This can be written as minus a and plus 1. This also can be written as 1 minus a. Okay, so this is the right hand limit. Now for a function to exist, both the left hand limit and the right hand should be equal. Okay, accordingly, so we can say that here when a is less than 0, the limit exists at any point for any value of a. Okay, so here LHL is equal to RHL, so we can say that limit exists for any value of a when a is less than 0. Okay, approve it. Now let's see what happens if a is equal to 0. Okay, now take the number line. Let this be the point 0, which a equal to 0. Okay, now a is 0, so the function for the left hand, now let x be approaching 0 or a from the left hand side and from both sides. Okay, now the function for less than 0 will be minus x plus 1, and for greater than 0 will be x minus 1. Okay, there are two functions now here. So this will be the distance h and this will be the distance h here. So here we can write x is equal to, we can write either 0 minus h or a minus h. Okay, because a is equal to 0, we'll take a minus h, and here x will be a plus h. Okay, now the left hand limit. So limit of the function as x approaches a or 0, okay, a from the left hand side is equal to limit f of a minus h as h tends to 0, which is equal to, now let's replace the function for the left hand limit here with a minus h. Okay, so limit minus a minus h plus 1 as h tends to 0. So this can be written as limit minus a plus h plus 1, multiplying the minus inside. Okay, putting the minus, h tends to 0. Now putting the value of h in the function, you get minus a plus 0 plus 1, or minus a plus 1, or this can be written as 1 minus a. Okay, so this is the left hand limit. Okay, now the right hand limit. Now let limit of the function be as x approaches a from the right hand side, a plus is equal to limit f of a plus h. Okay, x is replaced with a plus h as h tends to 0 is equal to, let's now replace the function for the right hand limit with x with a plus h. Okay, so this becomes limit a plus h minus 1, okay, as h tends to 0. Okay, so now replacing h in the function, we get a plus 0 minus 1, which is equal to 0 minus 1. Now here this is the RHL, left hand limit. Now you see the LHL and RHL are different. LHL is not, here it is 1 minus a, here it is a minus 1, so both are not equal. So we can say that limit does not exist when a equal to 0. Okay, for a equal to 0, Okay, that's it. Now let's find out whether limit exists for a greater than 0. Okay, now let this be the number line and this be 0, and for a greater than 0, let's take a point A here, and so the function for the x greater than 0 is x minus 1. Okay, now x is approaching a from both sides. This is the distance h. X is equal to a minus h, and here x is equal to a plus h. Okay, the position of x is a plus h. Here the position of x will be a minus h. Okay, let's find out the left hand limit. Now limit f of x as x approaches a from the left hand side, okay, so that is a dash equal to limit f of a minus h as h tends to 0, which is equal to limit. Let's replace the function x of the function with a minus h, so this will become a minus h minus 1. H tends to 0. Putting the value of h in the function, we get a minus 0 minus 1, which is equal to a minus 1. Is it? Yeah, okay, correct. This is the LHL. Okay, now RHL, right hand limit. So limit f of x as x approaches a from the right side, that is a positive, is equal to a plus is equal to limit f of a plus h, h tends to 0, is equal to limit let's replace x with a plus h. Okay, so a plus h minus 1, h tends to 0. Putting the value of h in the function, you get a plus 0 minus 1, which is equal to a minus 1. So this is RHL. Now here both LHL and RHL are equal. Okay, a minus 1, a minus 1. So we can say limit exist when for all values of a, when a is greater than 0. Okay, that's it. So limit exists for all values of a except a is equal to 0. Okay, at a. That's it.